Okay, today we are talking about rate of change. Rate of change. I'd recommend if you had maybe some colored pens or something like that, that'd be a good one to use for this one, just to help you kind of see what we're talking about. But so we're talking about rate of change. Okay, so first let's do a definition. Okay, so write this down, please. Rate of change describes how one quantity changes with another. Okay. So far, all we've been talking about is ratios. Like, let's compare this compared to that. But now we're going to talk about how things change together. Do they change at the same speed, right? So, if I have a job and, I earn $10 an hour, do I earn $10 every hour? Or do I not? Sometimes it goes, I earn $12. Sometimes I earn less, $9. Like, we want it to change consistently is what we're looking for. And that's what we're talking about with rate of change. Okay. What is the rate at which something changes? Pretty simple there on the instructions. Okay. Rate of change. Okay, so we're going to look at this from two perspectives, from a table and from a graph. Okay, from a table and from a graph. So let's start with from a table. Okay, let's say you are someone who is into buying model cars. Okay, like you like model cars or Hot Wheels or something like that, or bigger model cars, whatever. Okay, and so this is your cost cars, and this is money, how much it costs for those cars. Now, cars is going to be our x variable, and money is going to be our y variable. So let's say cost $5, or you want 5 cars, cost $40. 10 cars cost $80. 15 cars cost $120. And 20 cars will cost you $160. Okay, so you're really into buying these model cars. Go ahead and copy that down. All right, now normally what we would do, right, if we were to say, is this proportional or not, right, this is what we would do. You don't have to write this down. If we want to say, is this proportional, this is what we do. We'd say, okay, well, first of all, it's always y over x, okay? Again, you don't have to write this part down when I'm writing in blue. If you were to say, is this proportional, you would say, okay, well, 40 over 5, is that equal to 80 over 10? And you say, okay, yeah, those are equal, so that's good. That simplifies the same. Okay, how about 120 over 15? Okay, that's the same thing as 8 over 1, so that's good to go. And this is the same thing as 8 over 1, so that's good to go. All right, so you would say this is proportional, yes, right? Okay, again, you don't have to write this down. We would say this is proportional because we look at the ratios, and that's what we're talking about. We're just talking about the ratios, 40 over 5, 80 over 10, 120 over 15, so on and so forth. Right? Today, we're not dealing with that. What we're talking about is the rate of change. How much does it change? Okay, and you're always going to put your y over your x. All right. So this is what we're going to look at. We're going to look at how much does it change from one to the other. So from here to here, 40 to 80 it goes up by 40. Yeah? And from 80 to 120, and I want you guys to write this on yours, it goes up by 40. And from 120 to 160, it also goes up by 40. Now, what about the x? From 5 to 10, it goes up by 5. From 10 to 15, it goes up by 5. And from 15 to 20, it goes up by 5. So this is how you do rate of change, okay? The rate of change, okay, is equal to the change in y over the change in x. Okay, write that down. Change in y over change in x. So in this case, right? Let's look at this, right? How much did our y change from one point to the other? It went up by 40. So the change was 40. And how much did the x change? It changed by 5. So our rate of change would be 40 over 5. Okay, notice you're comparing not the two numbers together anymore. You're comparing how much they changed. So this simplifies to 8 over 1. Now, what we want to know is this a constant rate of change? Is that true for everything? Well, yeah, look. This is 40 over 5. There it is again. Which is still equal to 8 over 1. And then this last one, right here, 40 over 5. So 40 over 5, which is equal to 8 over 1. So this has a rate of change. And what is the rate of change? The rate of change is 8 over 1 in this problem. So the correct answer is, so the rate of change is 8 over 1. That would be your final answer. You guys see that? So we're comparing how much it changes, okay? Not the actual numbers. We're comparing how much it changes. Hopefully that kind of makes sense. We'll do some more examples. If it doesn't, that's okay. Okay, so let's move on. Let's try another one. All right, let's say you're going to a restaurant, or you're going to a, let's see, a boba place, something like that. You're going to buy a drink. That's our X. And money is our Y. All right, so let's just say you buy one drink and it's $8. Oh, that's expensive. But after that, your second one is only a total of $10. If you buy 3, it's only $12. And if you buy 7, it's $20. So maybe because the first drink you buy, you actually buy some popcorn chicken with it, and so that's why it's $8 total. But if you got 2 drinks and a popcorn chicken, then it's 10. And 3 drinks and a popcorn chicken, then it's 12. And you know you have a lot of friends, you're buying for your whole family, all that boba, right? Or maybe just for you. Okay, you're like, okay, well, I want a Thai tea, and I want jasmine milk tea, and ooh, feeling like an oolong milk tea. Okay, so let's check the rate of change here. Let's try to find the rate of change. So again, change in y, okay? This one goes up by 2. And this one goes up by, from here to here, same points, goes up by 1. So my rate of change is 2 over 1. Let's see if that's the same for the other ones, okay? How about from here to here? That's plus 2. From here to here is plus 1. So that's a 1. So far, so good, yeah? Okay, do this last one on your own and see if it comes out to the same thing. Okay, so some people might think, well, Mr. Young, no, it's going up by a different amount. That means it's not the same. Well, 12 to 20 is plus 8 over 3 to 7, which is a plus 4. Guess what? What happens when we simplify that? Right? We get same thing, 2 over 1. Yeah? So the rate of change for this table, okay, is that number that keeps showing up. Okay? 2 over 1, or a better way to put it maybe is $2 for one drink, like that. Okay? That's your rate of change. Now, here's a question for you. Is this proportional? Okay, Joaquin says no, no, no. I like that. This is not proportional, right? Because look, is 8 over 1 the same as 10 over 2? No, those are not the same, right? So it's not proportional, and that's okay. Doesn't have to be, right? Rate of change is just a separate. So they're similar, but they're also different. Okay, I want you guys to understand that. Okay, now, what does it mean from a graph? Really quick, let's look what it looks like from a graph. So let's go back and let's graph letter A. Okay, I'm going to graph letter A here. If you remember, letter A talked about cars and money. So I'm going to use, let's see, 5, 10, 15, 20. This is going to be 40, 80, 120, 160. You have a second to copy that down. All right, so what I'm using is I'm using the data that I had from this problem up here, okay, from problem A. So you guys should see it easier than me. Okay, so remember, 5 cars cost $40. 10 cars cost $80. 15 cars cost 120. 20 cars cost 160. Right? So you should get a straight line that goes to the origin. Remember, we did say it was proportional, so it does make sense. Straight line through the origin there. And to help us out, I'll just put the points here. So this is okay. Give me a second here. All right, so when you're looking at a graph, right? When you're looking at a graph here, what you're going to do is you're just going to go from point to point and see how much it changes in y. Okay, the y is the up and down, and how much it changes in x, which is your left and right. Okay, so I'll still use the red and the blue to help us out here. Okay, so let's just go from one point to the next. How much do we need to go up from this point to get to this right here? Okay, so from 40 up to 80, we need to go up by 40. And how much do we need to go over to get to that next point? Okay, we need to go from 5 to 10, which is a total of 5. You see that? So our rate of change remember, our rate of change is changing of y over x, right? Is 40 over 5, or 8 over 1. Right? We already knew that. Did we already know that? Look at the next one, right? Check it out. If I go up 40 and I go over 5, that's still this right here, 40 over 5. So on your homework tonight, there's a few graphs, and what you're going to need to do is you need to find out how much does it change in y, the up and down, and how much does it change in x, the left and right. And we're going to spend more time on this tomorrow. I know we kind of rushed through it, but it's the graphing part's a little bit tricky at first, but then if you get it, then actually 1/8 is pretty much the same thing, okay? What's cool about this, right, is it doesn't matter which 2 points you choose. So let's say, for example, I wanted to go from this point, oops, sorry, erase my line, oops, keep erasing stuff. Let's say I want to go from this point right here to this point right here. Well, let's think. How much do I need to go up? Right? I'm going from 80 up to 160. Okay? 80 up to 160 is up 80. And then how much do I need to go over? That's going from 10 all the way to 20, which is 10. Guess what? That's 80 over 10. What's 80 over 10? 8 over 1. Yeah? You see that? So all you're doing is you're choosing 2 points, and you're saying how much do you go up, and then how much do you go over? Up and then over. Okay? That's what it is. It's your this over your this.